1 minute, but you see that the data density is very high. And this curve is what you calculate from your in situ pH measurement and your in situ DIC measurement. And it is the carbonate saturation state and how it changes throughout the day. So this can be very important helping people study reef ecosystems. It's an important tool. This is some work that we did with Kim Yates' shark enclosure, submersible habitat for analyzing reef quality. And so we did work down in the Florida Keys with this, also putting in a DIC measurement capability and a pH measurement capability. This shows what we got over about a day and a half for the enclosure. And the important point about this is that we took discrete dissolved inorganic carbon samples, and you see that you get very good agreement between discrete sample measurements and the in situ sample measurements. In fact, it's about at just a little bit worse than the analytical imprecision, level of imprecision that you would get with a shipboard measurement. So this shows what you can do if you put all of these systems together. So this looks like a New York subway system, and there's a lot of plumbing and electronics here. And you put all this together and get it all set up. You can bring water on board and let this do its work. And so you can make measurements of pH, CO2 fugacity, DIC, and total alkalinity, all simultaneously chugging along. This shows some actual data that we got from the South Pacific, and in this case, these discrete points are discrete total alkalinity measurements measured by personnel from the University of Miami, and this is TA calculated from DIC and also our pH and CO2 fugacity measurements. So you see you have a high degree of coherence here. This is a recent development. So this is some work that was headed up by Bo Yang. This is a pH measurement you see in this data obtained from the Gulf of Mexico, obtained with state-of-the-art measurements using about a $12,000 Agilent 8453 spectrophotometer. These circles are data obtained with an LED photometer. So Bo went to Radio Shack and with less than about $100 in parts built a handheld LED photometer and can obtain measurements that are in excellent agreement with the state-of-the-art measurements. In fact, the level of precision is lower, of course, but this is ideal, being so cheap, for measurements in the bay where if you measured here and then took 3 steps and measured over here, you'd see changes that were greater than your precision anyway. Some of our most recent work is involving measurements of the, we're involved in a competition, the Wendy Schmidt Open Ocean Health X Prize competition. We're in it for the Accuracy Award, and along with many other contestants. And this is an endeavor that involves USF, SRI St. Petersburg, and also Battelle Memorial Institute in Columbus, Ohio. So here shows, this is really a 4th generation instrument. This right here was machined by Battelle, and it's all titanium. So this will get us down to the 3,000 meter depths where some of the other contestants later in the year are going to go And this shows one phase of the competition, some stability tests in the Mbari test tank, and this shows our entry right here with the copper cladding to eventually protect against biofouling. So our current NSF-funded work in this area of research involves, with SRI St. Petersburg, the development of an inexpensive sensor system where we can put everything in a Pelican case. Somebody can trundle it off to a seashore someplace, open it up, put it in the water, turn it on, and measure all 4 CO2 system measurements very simply. So that's one project that we have going. And we also have a very challenging investigation, which is an investigation of the seawater CO2 system thermodynamics in seawater. So what this involves is making state-of-the-art CO2 system measurements. So we make measurements as well as anybody in the world does for DIC, pH, CO2 fugacity, and total alkalinity. And this can be done with great care. But what we're trying to do then is to investigate the thermodynamic model that relates to those different variables. Because if you use two of the variables to calculate a third, no one ever, on average, gets perfect agreement. You can end up with discrepancies. There's something wrong in the model. And this has been known for many years, but we don't know what the origin of this is. And so this is really fun work to do this, and I hope we get to the bottom of the mystery. So I want to thank all of the various people, and not every person that should be thanked is on here, but this shows some of my earliest students, Mike Morris, and a host of others. So some of you guys are out there now. Thank you.
We have a couple minutes for questions. Yeah.
Bob, your figure on the hots and baths pH relationships, it looked like at the Bermuda station, the dynamic range of the samples was higher than in the Pacific. What's the reason?
One of the reasons is there's eddies moving through that system, and so they end up with excursions because of variations in the physical oceanography there. There may be another hidden reason, I suspect. They adopted the spectrophotometric techniques later, and so maybe there may be some artifacts in it too.
Working with small volumes and respiration, any potential for your techniques to make the Clark electrodes obsolete, so we can use these techniques with small volumes in determining respiration rates?
Well, I absolutely think so, and I don't think anyone has tried to do this yet, but one of the things you can recognize, even if you have a 1 meter path length, the volume inside a 1 meter path length of the liquid core waveguide is about 250 microliters. So if you go down to the necessary 10 centimeter path length, the volume that's required for micro measurements is very small, and we can make a number of different kinds of measurements, so I absolutely think that people could use these techniques there.
Well, let's thanks. Oh.
How much is Oceanoptics worth now?
I don't know. I haven't been involved with them for maybe 10 or 15 years. In fact, I was only involved really in that early stage, and then I communicated with Mike Morris, but I wasn't involved with any of their internal workings or anything. But they were acquired by Halma. I didn't hear what you.
Shouldn't he give us a for the Dean's Innovation Fund?
He actually did.
Things like
Mike made a major contribution, which was up in maybe 100,000 or so, maybe even more than that. But he's always approachable, and he's still an entrepreneur. So, yeah.
Let's thank Bob again.